Right. Chapter 8, Section 2. The nice thing about this section is it doesn't really rely on the last section at all. We'll tie the topics together later on in the chapter, but right now we're just kind of working on some of the basics with these rational expressions. And rational expressions, before we get too far into it, is just a great big fancy way of saying fractions. Now, these aren't the fractions that you were using in third grade. We're not looking at 2/3 and 7/5. We'll be looking at things that are more appropriate for an Algebra 2 class. But the nice thing is that all the fraction rules that you learned way back in third grade still apply. The downside is how many of you remember all the fraction rules that you learned back in third grade? 1, 2, 3, about 5 of you. Great. Oh, what? Oh, I have a thing from table 8. Oh, don't you just put it in the calculator, make it a decimal? No, you cannot do that anymore. So, anyway, today we'll be multiplying and dividing rational expressions. Our learning targets for today: I can simplify rational expressions. We'll be doing a lot of simplifying. And I can multiply and divide rational expressions. Being that the topic is multiplying and dividing rational expressions, you should have really seen that one coming. So let's start with simplifying, because simplifying is going to be throughout everything that we do today. There are 3 steps to simplifying. The first step is you're going to factor the top and the bottom. Then you're going to identify where it is undefined. That means you're going to look at the bottom, what would make the bottom equal to 0. And then you're going to cancel the common factors. That's my favorite step. It's a lot of fun. It's way more fun with an actual pencil or pen or piece of chalk than it was doing it on the computer, but we'll make do. So let's look at a simplifying problem. 4x to the 4th divided by 2x minus 6. So the first step, we need to factor the top and the bottom. The top's already factored. There's no addition or subtraction. We don't need to worry about that. The bottom, first step of factoring, factor out what they have in common. Hey, these are both divisible by 2. So let's pull the 2 out. We're left with x minus 3. All right, now identify where it's undefined. What would make the bottom equal to 0? Well, the 2 could equal 0, but the 2 is not going to equal 0. The 2 is going to equal 2. Or the x minus 3 could equal 0, which means that x would have to equal 3. So this can't be 0, so x can't equal 3. That's all the identifying word is undefined is. With the simplifying questions, we're doing it for practice. We'll see why that's important at the end of the lesson. All right, now we got to cancel out common factors. Hey, we have a 4 and a 2. We go, sha! Cancel it out, and we're left with 2, which leaves us with 2x to the 4th over x minus 3, and we know that x can't equal 3. That's simplified. That's all it is. Let's look at one that's a little bit more exciting. This will have more factoring. 6x squared plus 13x minus 5 divided by 6x squared minus 23x plus 7. We're going to factor the top and the bottom separate. So we're going to get our 2 sets of parentheses. What times what equals 6x squared? What times what equals negative 5 and 7? Things like that. So factor the top and the bottom separately. Let's see how you do on this really quick. You can pause it if you need a minute or so to factor this, or you can factor it while listening to the smooth sounds of my electronic voice. Do you have it yet? How about now? Do you have it? All right, well, let's see what we got. I got 3x minus 1 times 2x plus 5 and 3x minus 1 times 2x minus 7. Check our work. 3x times 2x equals 6x squared. 3x and 5 is 15x minus 2x is 13x minus 5. In the bottom, 6x squared. We have minus 21x minus another 2x is minus 23x. And negative 1, negative 7 is plus 7. So this is probably the hardest type of thing that we're going to factor in this whole topic. Most of them are a lot easier than that, but it's good to have a hard one as an example. All right, step 2, identify where it's undefined. Well, 3x minus 1 can't equal 0, which means that x can't equal, so we add the 1, divide by 3, so 1/3. Or over here, x can't equal 7/2. We add the 7, divide by 2. So x can't equal 1/3 or 7/2. Now we get to cancel out what they have in common. Yeah. See how much fun that is? Wait till we get to cancel more. It's very exciting. Anyway, we're left with just this, 2x plus 5 over 2x minus 7. And we know that x can't equal 1/3 or 7/2. All right, how about another one? X plus 4 over 3x squared plus 11x minus 4. First step, we need to factor the top and the bottom. The top is already factored. There's nothing we can do there. So the bottom, 3x squared plus 11x minus 4. Two things that will multiply to be that are going to be 3x and x. And so see if you can factor the bottom there. I would be very surprised if we didn't end up with an x plus 4 as a factor in the bottom. So if you need to use that to help, go ahead, at least as a first guess. Do you have it yet? All right, let's see. I have 3x minus 1 and x plus 4. So that would be 3x squared plus 12x minus x is plus 11x minus 4. There we go. I put parentheses around the top. It doesn't need parentheses, but when we cancel, sometimes just having those parentheses makes it easier, and it keeps us from doing something horrible like just trying to cancel out an x and leaving the plus 4, because we know that we don't want to be that guy that does that. So the parentheses just help say, hey, this is one thing. And so now identify where it's undefined. 3x minus 1 can't equal 0, so add 1, divide by 3. So x can't equal 1/3 or negative 4. And then we can cancel. Yeah. And we're left with 3x minus 1. Oh, no, wait. That's in the denominator. What do we have left on top? That's right, a 1. 1 over 3x minus 1. One of the big mistakes here, people cancel that, and then magically this denominator moves up to the numerator. No, when you cancel it, if there's nothing left, it's a 1. And so we have 1 over 3x minus 1, and x can't equal 1/3 or negative 4. So that was simplifying. We're going to get a little bit more practice simplifying here, because that's going to be something that we have to do when we're multiplying and dividing as well. But factor, figure out where it's undefined, and then cancel the common factors. So let's take a look at multiplying rational expressions. And when you're doing this, one of the directions, like it'll say multiply, assume that all expressions are defined. And same thing with division. Divide, assume that all expressions are defined. That just means we don't have to worry about the denominator equaling 0 and weird stuff happening. So we don't have to go through and figure out where it doesn't equal 0 for these. We can just assume that it doesn't. So let's look at some problems here. Here's a problem. So we have x minus 2 over x minus 3 times 2x minus 6 over x plus 5. Our steps here, the first thing we're going to do is we're going to factor this. We're going to factor, then we're going to multiply, and then we're going to simplify. So factoring this one, x minus 2 is already factored, x minus 3 is already factored, x plus 5 is already factored. The 2x minus 6, they both have a 2 in common. So we can pull out a 2 and we're left with x minus 3. And I put everything else in parentheses. And now we're going to multiply. The multiplication step is fun. Are you ready? Did you see what happened there? We multiplied. Here, we'll do it again. Ooh, all that happened when we multiplied, this fraction bar went across the whole thing. Because when we multiply fractions, we multiply the tops and we multiply the bottoms. We multiply the tops, we multiply the bottoms. So the multiplication step is done. That's all it is. Just draw the fraction bar straight across. And now we need to simplify. It's already factored for us, so we get the fun part of simplifying. Canceling. Yeah. And there we go. We're left with x minus 2 times 2 over x plus 5. I'd pull this 2 out in front just because we like 2 times x minus 2 as opposed to x minus 2 times 2. It doesn't matter, but that's more common. If you really wanted to, you could multiply this out, but I wouldn't. You don't need to right now. And if there's anything we're going to do to it, most of the time we're going to want it factored anyway. So I would just leave it like this. All right, let's take a look at another one. This one will be a lot more fun. So we have x squared minus 16 over x squared minus 4x plus 4 times x minus 2 over x squared plus 6x plus 8. So here we get to factor a lot more. And notice these guys are a lot easier to factor than the ones we had with the 6x squareds. This will be more typical of what we're doing. And so let's factor. X squared minus 16. Let's see. They have nothing in common. Hey, there's only 2 terms. It means it's probably a difference of squares. Is this something squared minus something squared? Let's see, what squared equals x squared? That would be x. What squared equals 16? 4. That means we're going to have x plus 4 times x minus 4. The x minus 2 is already factored. See if you can factor the 2 denominators. These are pretty easy factorings. In fact, you should really already have them done by now. I've been yammering on. You should have them done. Yeah? No? All right. Take another few seconds. All right. You have them? Pretty much? Almost? All right. If you don't have them yet, pause it till you get them. So, x squared minus 4x plus 4, I get x minus 2 times x minus 2, because negative 2x is negative 4x, and negative 2 times negative 2 is 4. The x minus 2 was already factored. Then x squared plus 6x plus 8, x plus 4 times x plus 2, because we have 6x plus 2x. 4x plus 2x is 6x, and 4 times 2 is 8. All right, now for the multiplication step. Whoop. There we go. It's multiplied. And then simplify. We've got lots of stuff to simplify here. And, that was it. Darn it. We have more later. Anyway, so we're left with x minus 4 over x minus 2 times x plus 2. And that's it. We could multiply this out to get x squared minus 4, but I've seen people do that, and then they cancel out the minus 4s, which is a horrible, horrible thing to do because it's through addition. And they have x over x squared, and they'll cancel out and get, instead of 1 over x, they actually get x. I've seen people take this and simplify it all the way down to x. Don't be that guy. Just leave it like this. So that's multiplying. Really, it's just simplifying. We just have to extend the fraction bar. Other than that, it is just simplifying. Division is basically the same as multiplication. And remember, the division will also have the assume that all expressions are defined, so we don't have to worry about that. But how do we divide? To divide fractions, we take the one after the division sign. We're going to flip it upside down and multiply. So this, notice this one's the same. Then we just flip this one upside down. Then we can multiply. At this point, you could cancel things. Like, hey, we have a y and a y. Or for a problem like this, I'd just combine our like terms. X to the 5th times x to the 3rd. When we multiply things, we add the exponents. So that's x to the 8th and y to the 5th. And then 1 times 3xy is just 3xy. And now we can divide x to the 8th over x. That's x to the 7th. Y to the 5th over y. That's y to the 4th. So we have x to the 7th, y to the 4th over 3. This one wasn't all that exciting. It was just the, hey, how do we divide? So let's do a more exciting one. Here's a more exciting one. This one we get to factor all 4 pieces, so it's very exciting. But before we do that, I would flip this. You can do it after you factor, but I find that people forget, or once you have factors, you'll flip some of them, but not all of them. I would rewrite it first with multiplication. So flip it upside down and just rewrite it. Now we can factor it. All right, these ones are pretty easy. Notice the one down here is difference of squares. So go ahead, pause me for just a minute and factor these 4 quadratics. And then when you're ready, push play and we'll continue. Did you actually pause me and do this yourself? Come on, participate in your own learning. Actually factor them. All right, pause it and try again. All right, for those of you not listening, actually pause it and factor them on your own. Don't wait for me to do it for you. All right, chances are we got all but 5 of you now. So let's factor these. The top one, I get x plus 1 times x plus 1. The one down below, x minus 6 and x plus 3, because we have minus 6x plus 3x is minus 3. And then multiply, give us negative 18. Up here, minus 6 and minus 1. Then x squared minus 1, that's x plus 1 times x minus 1. We can multiply, and then we can start canceling. We have x minus 6's, we have the x minus 1, and we have some x plus 1's. All those cancel, we're left with x plus 1 over x plus 3. This big crazy thing simplifies just to x plus 1 over x plus 3. And you get to do all sorts of cha-cha-cha-cha-cha with those. And yeah, if you're not enjoying it, try and enjoy it. It's okay. Especially right now, you're in the privacy of your own home. You can do it, nerd out just a little bit, get excited by slashing those factors off and making the problem easier. And there's no one there to laugh at you, even though right now you may or may not be laughing at me. But that's okay, because I'm laughing too, so really you're laughing with me. Anyway, the next and last thing that we're looking at is solving one type of rational equation. We're going to be solving rational equations in a few sections, but for whatever reason, they included this type of rational equation here. These are all solved exactly the same, and it shows us why we need to figure out what x can't equal. So, how do we solve these? We're going to simplify this side. So these are always going to look like a quadratic over a line equals a number, the ones you're doing today. We're always going to simplify this side, which means you're going to factor the top. One of the factors is going to be the denominator in these. So my guess is we're going to have 2x minus 3. Let's see. So 2x and x would give us 2x squared. Negative 3 and positive 5 would give us 15. So I'd start out with x plus 5. And check. Let's see. 2x squared plus 10x minus 3x is plus 7x minus 15. Hey, look at that. It worked. Now we need to figure out what x can't equal. Look at the denominator. So this can't equal 0, so we'd add 3, divide by 2. X can't equal 3 halves. And now we can cancel. So we get x plus 5 equals 10. Subtract 5. X equals 5. Can x equal 5? Yep, that's not 5. So x equals 5. That's it. That's solved. Let's look at another one. 16x squared minus 9 over 4x plus 3. We can factor this. This one's a difference of squares. What squared equals 16x squared? That would be 4x. What squared equals 9? 3. So we have 4x plus 3 times 4x minus 3 over 4x plus 3. Figure out what x can't equal. That we subtract 3, divide by 4. So x can't equal negative 3/4. cancel. We get 4x minus 3 equals negative 6. We add 3. 4x equals negative 3. Divide by 4. We get x equals negative 3/4. Can x equal negative 3/4? Oh, x cannot equal negative 3/4. This one right here wins the battle. So, if x can't equal negative 3/4, but that's the only thing that x can equal, what do we have? No solution. What this would look like if we graphed it is it would look like a line, but there'd be a little gap right here. So it's a line everywhere except for this one point where there's just this little hole, and we'll learn about those later on in the chapter. But so x just can't equal that number, and that's the number that x would equal if it could, but it can't. So no solution. And you could write out no solution if you want, but the symbol is perfectly acceptable as well. So this was multiplying and dividing, which included simplifying. In fact, it was almost all simplifying, and included just this little bit of solving. Some of our topics have a lot of stuff in them. This one didn't. It was the same stuff over and over and over again. So hopefully you remember your multiplication and division of fractions at this point, and you can probably see why just sticking them into a calculator is not going to work for us. This is not going to become a decimal. So anyway, don't forget to post a comment, and I will see you in class.